Okay, I'll provide you that through Prachi. All right. So good morning, everyone. Let's get started. Our topic is big data, right? And I will assume that you have no idea what exactly big data is. We'll start basically from the beginning. Okay. So big data, when you say, like the word itself says, big data means huge volume of data. Is not it? So big means what? Huge, and data is just the data, right? Now, whenever you say that big data, that means you first have to understand what is this big data, how much size makes it a big data, right? Can I say a 10 MB of data as big data? Can I say 100 MB of data as big data? Can I say 200 MB of data as big data? What is the size that defines the big data? That's the important question. That makes the data as big data or non-big data. Okay, you cannot go to your boss saying that I have to process a 10 MB of data and I need a big data solution, right? So there has to be a like a benchmark to decide whether the data is big or not. Okay, now every computer, right, every computer has their own CPU, right? Like I would say 4 cores, has their own RAM, let's say 16 GB RAM, has their own hard disk, let's say 2 terabyte of hard disk, right? Now, if I talk about this system has CPU, 4 cores, 16 GB of RAM, and 2 terabyte of hard disk, right? And now, if I want to process a data of, let's say, 100 GB, only 100 GB, okay? If I want to process data of only 100 GB, now see, 100 GB of data can be easily stored here because the size, the capacity of this system is 2 terabyte, okay? So 100 GB you can easily process here, right? So you store this data in this in this node, and you have stored the 100 GB of data successfully. Done. Now you started processing this data. Now how are you going to process the data? By writing some code, right? And that code could be a Python code, that code could be a Java code, or that code could be a big data Hadoop, MapReduce, or maybe Spark, or maybe other ecosystem code. Okay, we'll talk about that ecosystem later. So suppose the requirement was very simple. There was a file, or there is a file which has employee ID, employee name, and employee salary. Okay, likewise you have a lot of data, and this data is what is making 100 GB, is not it? Now if I say I want you to tell me the total salary of all the employees, right? So if you are using SQL, then you will write SQL queries. But if you're not using SQL, if you want to do it using Java or Python or anything, then you will basically take this data and then start adding them, right? And that's what you do, right? So now suppose you have written some code. Okay, we will not talk about the code right now. This is the introductory session today. So suppose you have written a code, and that code runs on this data, but it is taking, let's say 200 hours. Okay, let's say it took almost 200 hours to process this data, or maybe let's say 240 hours to make the calculation very simple. Okay, so let's say this code, the code whatever you have written is taking around 240 hours to process just 100 GB of data. Now you should go to your boss and say, hey boss, I have written a program to process this 100 GB of data. The program runs very, very well, but the only problem is it is taking 240 hours. 240 hours means exactly 10 days. Okay, so that means you have the data 100 GB which you are able to store on your machine, right, without any problem. But the main problem is where when you started processing the data, it is taking 10 days. Now you can think about, the boss will say, okay, but tomorrow also we are going to get 100 GB of data. Again, after on day 3, I'm going to get 100 GB of data. Again, on day 4, I'm going to get 100 GB of data. So you are actually taking 10 days to process 100 GB of data. So 10 days, again another 10 days, again another 10 days, again another 10 days. So it will almost take 40 days, right? Of course. So when you are processing this data, maybe you will not be able to process this data. Why? Because all your RAM and cores are busy processing this data, right? So at the end of the day, this 400 GB of data you are taking 40 days to process, and the company may say no, right? The company may say your solution is not efficient. We want this data to, we want this system to give us data maybe in just 2 hours, right? And now you are gone. How are you going to speed this process? You are taking 240 hours to process this data, but how are you going to speed up this process, right? You have no clue, right? Because you don't know what is big data, right? So what I'm trying to tell you here is, in big data you have to consider minimum two things, okay? Whenever you say it is a big data or not, you have to consider minimum two things. One is size, okay, size. The other one is processing time. So these are the major two factors which should decide whether the data is big or not. Okay. So if the size is small enough to fit in a single machine, right, you call it a small data. Again, if the processing time that is taken is acceptable by your company, you will call it you will still not call it a big data. Okay. So if the size is under control, that you are able to store it on a single machine, and if the processing time is such that the company has no problem, okay, with 10 days or 40 days, then you will not call it a big data, you'll call it a data, a simple data. Okay. But if the requirement is the processing time should be minimized, or the size is, the data is so huge that you are not able to store it in a single disk, then you call it a big data. Okay. So I hope you understood what is a big data, right? So big data means the data whose volume is either so high that you are not able to store it in a single machine, or the processing time is so high that you are not able to, like, solve the problem or process the data within a given time frame, and that is not acceptable. In those cases you go with big data concept. Okay. So big data, if you say big data is a problem, okay, big data is a problem, and there are so many solutions of big data. We will talk about that. So if you have no questions, you can just say no questions in the chat box, and I will understand that you guys are clear with whatever we have discussed right now. Any questions, guys? You can just type no, and I will understand that you understood everything whatever we discussed right now. Great. Okay, so now let's talk about what is this big data, right? As I have told you, the big data is basically a problem. Okay, big data is a problem. It is not a solution, right? So what is the problem? The problem is either the data is very big, right, or the processing time is so high that it is not acceptable. These are the two problems, major two problems. Okay, what are the problems? Data size and processing time. Okay, and processing time. These are the two problems. Okay, so now to solve these problems, there are many technologies that are available in the market. Okay, most popular are Hadoop, Spark, and so many other. There are so many other framework you have not even heard of, Hydra, Disco, okay, and so many. Okay, now there are so many tools, there are so many softwares available which are basically designed, especially designed to solve this big data problem. Okay, and what is the problem? The main two problems are size and processing time. The data is so big that I'm not able to store it on a single disk, or the data is so like the processing time is so high that the company is not accepting it. They are the major problem, right? So now you have a lot of tools in the market like Hadoop, Spark, Hydra, Disco, and there are many more. 15-20 tools are available in the market. Okay, now what makes Hadoop so popular and Spark so popular are they are from Apache. Okay, they are from Apache. They are open source. They are open source. What do you mean by open source? Open source means the developer of this tool, Hadoop or Spark, they have also given you the source code. Okay, so that you can look into the source code, and if you feel that you are quite capable enough, you can go ahead and start contributing to it. Okay, that is called as open source. Open source are always a free software, always free. Okay, but not necessarily that all the free software would be open source. Please understand this. Okay, all free softwares need not be open source. For example, what is a free? Let's try to identify what is the software that is free. Can I say MS Paint is free? Because the moment you install Microsoft OS, right, Windows operating system, you get MS Paint. You don't have to purchase it separately. It's free. It's free, and that comes with your Windows operating system. But do they give you the source code of it? No, right? So that means the software is free, but you don't get a source code of it, right? Versus all the Apache product like Hadoop, Spark and all, so they are basically from Apache, and Apache is basically an open source software provider who provide the software along with the source code. And why do they give you the source code? Because if they if they are giving you the source code, then what happens, many people come forward, they look into the code, they understand the problem, they make it more better, and that is how Apache software are getting a lot of popularities. Okay, now when I got my first laptop in 2007, when I was in BTech second year. Okay, BTech second year, the configuration of my laptop was 80 GB hard disk. Okay, 512 MB of RAM, and dual core. Okay, this was the configuration in 2007. In 2007, okay, and now, in 2021, right? The laptop which I'm using right now for presenting you, it has 2 TB of SSD, okay, and it has 64 gigs RAM, and it has 8 cores i9 processor. Right now, why I'm explaining you this is, see, over the period of time there is a lot of technological development, right? Earlier these were so, like, they were so costly. See, 512 MB of RAM was costing me around, this whole system cost me around, I think, 45k long back in 2007. Okay, and this is basically my MacBook Pro, which cost me around 400,000. Okay, but anyways, so now if you see this, in this era you have a SSD versus your hard disk, right? Hard disks are slow, SSDs are quite fast. 80 GB, 2 TB, 500 MB RAM, 16 times more better, right? And dual core, again, it would be basically one core and 2 threads mostly. Okay, and these are proper 8 cores, so I can say 8 times more better, right? So over the period of time the technology has evolved, and what you get now is you get a very good configuration system, right? Same thing is with the servers as well. Okay, so when we talk about big data, when we talk about companies who are using big data, what they do, they buy servers, and those servers are very costly. Earlier, back in 2007, those server had minimum capabilities. This in 2021, the servers are much more powerful, right? So in today's era, what is cheap? Storage is cheap. Okay, and earlier what used to happen is, no, you did not had a concept of big data, because of which many people were not able to solve the big data related problem. Okay, for example, let's take one use case. Okay, now suppose in India, there are so many states, and we want to install 10 ATM machines of State Bank of India. Okay, State Bank of India says, I have a permission to install 10 different machines in this whole India. Which are the top 10 places where I should basically go and install? So what we should do is, basically, we should take all the ATM which are available in the whole, in the whole country, right? You should take up all the ATMs. Maybe you'll take SBI ATM, you'll take non-SBI ATM, you'll take all the data of the ATMs, okay? And then you'll try to find out in which ATM the number of volume of transactions are more, right? Plus the number of amount that is been discarded is more, right? So you have to do some analysis on it. And let's say I want to like go through the data of last 1 year at least, not just 1 month, right? I want to go and I want to analyze the data of 1 year, so that after analyzing the data for a year, I can understand that, okay, in this area, there are more people who are using ATM, or in this area, there are people who are withdrawing a heavy amount. For example, any ATM machine you visit on Hyderabad, people would definitely, every single individual basically would withdraw, let's say, 12 to 15,000 per month easily. Why? Because they have to pay rent, and the owner does not accept online payment most likely. Okay, but if you look into some like area like, let's say, Odisha, a small town Jharsuguda, where I am currently staying. Okay, now here hardly people would On an average, people might withdraw only 2000 rupees because that's okay. They don't pay this much big rent, right? So likewise, people have to analyze what kind of data is coming, how much is the volume, and like they have to store this data and start processing the data, right? So as I've told you that big data has a lot of tools available in the market, out of which Hadoop and Spark are quite popular. These two are the market leader in data processing. Okay, now. Uh, so I've been working on data engineering since last 8 years, and I have been working with so many companies, and I have seen there are a lot of requirement for data engineering. Okay. Now, before we move forward, what I would also like to tell you is there is a big confusion among the people, and let me clarify it right away. Okay. So the confusion among the people is: shall I learn data science or shall I learn data engineering? I mean, big data. Okay, so I learned data science or data engineering, big data. Now the question is this, right? Because you can see all the people who are freshly graduating from the market, they are so crazy about data science. Okay, and many people don't even know what exactly is a data engineering. Okay, but let me be very honest that in data science you have a lot of people learning data science. Okay, maybe open any YouTube channel, see the amount of subscriber would be very high because everybody wants to be a data scientist. Okay, so that's the problem. So many people are learning this data science. Okay, versus the requirement is less. Okay, so if I say, let's say there are 100 requirements, then most probably 10 lakh people are learning data engineering, data science. Okay, for 100 requirements, versus if I say data engineering, now if I say if I have 100 requirement, then maybe 10,000 people are learning, or maybe 1 lakh people are learning. Okay, 1 lakh people are learning data engineering. Now I am also sure that many participants who are here, they also had this confusion: shall I take data science course, or shall I take a data engineering course, right? But what I'm telling you is data engineering has a lot of market, and it has created a vacuum now because everybody is learning data science by just assuming that they will get a very good opportunity. But the problem is the requirement is very less. Requirement is very less. Also, a practical example. Okay, I'll show you a practical example of what I'm exactly telling you, right? So let me share my screen, and I'll just open a browser. Give me a minute, I'll answer all of your queries, guys. I'll go to my LinkedIn, okay, and let me open jobs. Let me open jobs. I am going to my jobs, okay, and let us try to search for data science. Okay, I just clicked on data science. Okay, and then see the result what I'm getting. I'll write it on the board: 24,746. 24,746. Okay, 24,746 is the result for data science. I'll say data engineering, data engineer. Okay, now see here, 32,195. Okay, so I will not tell you something which is really false. I basically would like to show you the practical proof. I have shown you a practical proof in LinkedIn that for data science the total number of opening is this, and for data engineering the total number of openings is this. Okay, now you may have a question: okay, this looks very similar, is not it? I totally agree, but what about the total number of learners? Right here it is almost 10 lakh. Here almost it is 1 lakh. Okay, and that is a fact. And if you want to check this fact, as I've told you, open any YouTube channel, look for data science channel, look for data engineering channel. You will see a lot of subscriber here. Why? Because everybody is so crazy enough, they want to be a data scientist just to be a part of this 10 lakh people, and the vacancy are less than a data engineering. Okay, now let's understand what makes you a good data engineer, right? What are the syllabus basically you should basically follow, and we will talk about the big data after that. Okay, so most likely I would say like a data engineering contains a lot of tools, maybe 20-30 different tools. You don't have to master all of them. Okay, if you are good enough in understanding the MapReduce framework, Hive, very important, every company uses it. Okay, Scoop, HBase, Oozie, probably Spark, okay, and Kafka. So these are some of the mandatory things which you should know, okay? And if you know them very much in detail, then definitely you can be a very good data engineer. It takes time, right? So once you finish off your training program, you have to practice everything, and then it takes little time for you to understand all these things. And once you're done with all these things, you are like good to go to the market. And of course, a programming language is required here. So few people prefer Java, few people prefer Scala, few people prefer Python, okay? And then that's how it is. There are more openings for Scala and Python, okay? Java with Spark is not a great combination, okay? So you'll be basically you should basically master all this stuff, okay? I'll go to the next topic. Let me see if I have any questions from the participants. If you have any questions for me, please feel free to type it out, and I'll see that in my free time. Okay, so Vinay, I think I have already answered this question. Like, why should you choose data, engineering? Because see, at the top level, when you say from job point of view, there are two things which are very much trending. Okay, data science and data engineering. These are the two things which is very much trending. Why should you not do a web development? Okay, see, data engineering has a lot of better package than a web developers on an average. Okay, I'm talking about on an average. And why should you choose data engineering and not data science? I'll tell you, data science is not so easy to master, guys, because data science needs a lot of maths, statistics, and all. Okay, and a lot of algorithms and all. People feel writing two lines of Python code can make them a data scientist, but no, you'll be just one out of those 10 lakh people, right? You'll be just one of those 10 lakh people completed the course, and then you have no clue where exactly you want to proceed next. I know a guy who is working as a data scientist at 5,000 rupees a month. I know a guy who is working as a data scientist with, I think, 5 lakh rupees a month. Okay, so chances are that you can fall into this category, you can fall into this category as well. Okay, but data engineering has a wonderful openings in most of the companies. Like you name any company, there are openings in data engineering as well. Just go to the LinkedIn, open your LinkedIn and start looking into the data engineering, right? And you should see there are a lot of jobs. Look into the companies. Citibank hires, Infosys hires, TCS hires, Walmart hires, Facebook hires, Amazon hires, everybody hires data engineers, right? Of course, data science also, we have a lot of scope, but what I'm trying to tell you is if you look into the LinkedIn, the number of people who are learning versus the number of requirements are, this ratio is very high versus data science. Okay, so now it is up to you what you want to choose, right? It's completely up to you. Sir, till all lecture happen in English. So do you guys want me to talk in Hindi? Okay, many people says no. So let's because it's possible that few people are not very good in Hindi, and then it would be very hard for them to digest, right? But that's okay. I don't speak a very hi-fi English. I keep it very simple, so you should be able to follow me up. All right, let's move on. Now we will talk about what we will talk about Hadoop. Okay, we'll understand what is this Hadoop, how actually it came into market, what is the story behind it, and we'll take it forward from there. So any questions, guys, please type it on the chat window. Don't hesitate to ask me any simple question, because I'm the guy who would be basically taking care of your training on Hadoop and other components. So whatever questions, I would be the right guy to answer your questions right away. Okay, so please keep typing, and I'll look into your questions at the end of the session. Now, we're going to talk about what Hadoop, right? So if you look into this Hadoop, okay, Hadoop basically contains two important concepts. One is your MapReduce, and the other one is uh, SDFS. Okay, so let us understand the history of this Hadoop. Okay, somewhere down the line, maybe I don't remember the date, but I think it was around 2005 or 2006. I don't remember the date. So somewhere around this time, there were a couple of projects going on. I'll bring my marker today. My markers are all done. So somewhere in 2005, okay, there was a project going on at Yahoo, okay, and the project was all about bringing the big data, a huge volume of data from the internet, right? So from the internet, whenever there are new pages, new website hosted, there used to be a crawler, and crawler job is to get all the information from the internet and store it on a server. Okay, so we had a web, this is our web, okay, and there was a crawling software which was bringing the data to this machine, and this machine was a server. Okay, this machine was a server where we were bringing all the data from the web and doing some processing on this data. Okay, and the biggest problem was every day, you know, every day the data size was growing like anything, right? And the people who were actually working on these projects were Doc Cutting and Mike Cafilera. Okay, Doc Cutting and Michael Cafilera. So these were the two chief scientists who were working on this project, right? And these people were actually trying to get the data from web and start processing the data, right? And the problem was every day the data size was increasing. Okay, and I'm telling you the story of around 2005, 2006. Is not it? Now you can think about the compute capacity of the systems. Okay, so you can think about the compute capacity of the system. The compute capacity of the systems were not so great, right? And then the problem was they were not able to load the data a lot. Okay, so initially, let us assume they had 100 GB of hard disk. Let's assume, okay, because I told you that in 2007 I had a laptop with 80 GB of hard disk, personal hard disk. Okay, so let's assume the server had 100 GB of hard disk. Okay, and then they brought some data, and after some days this size was not able, this space was not enough to hold the data altogether, right? So what they did, they added more 100 GB to the existing system. Okay, and again it went well for some time. Again they could not, you know, hold more data, because after a few days again more 100 GB of data came. Again they started scaling it up, right? So they started adding more and more disk to your server. Okay, and at the same time, when you are adding a lot of data, right, your CPU would not be sufficient to process the data in the same given time frame. So what they did, they started also improving the cores. So maybe initially they had only 2 cores, then they incremented it to 4 cores, then they incremented it to 6 cores, they incremented it to 8 cores, and so on altogether, right? So these guys were literally frustrated. Why? Because they knew that even though they were scaling it up, they knew that there would be a time when this system would not be sufficient, because daily the data is coming, right? I have a small room, okay, and I see that one by one people are coming into my room. Okay, I said, okay, I can adjust with one guy. Again, one more guy came. I said, okay, I'll keep you as well. Third guy came, fourth guy came, fifth, sixth, eighth, ninth, 50th. Now I'm in trouble. What should I do? I have to process all of them. Is not it? So that was the problem here. Okay, so when these guys were facing a lot of problem, okay, uh, when these guys were facing a lot of problem, there were a few folks at Google. There are a few folks at Google who are actually working on the distributed technology. Okay, and they came up with two research papers. We call it GFS. We call it MapReduce. Okay, so when we say papers, that means just the theoretical just the theoretical understanding of it. For example, you ask me how to prepare a tea, I'll tell you very nicely that take some water, take some milk. If you want to mix some water, put some water, and you know, like heat them for some time. Put some tea, put some sugar, or maybe sugar free, or maybe cinnamon, cardamom, whatever, you know, turmeric, or whatever you want to have, and then you prepare the tea. It's not it. So if now when you ask me how to prepare a tea, I gave you some idea, but that does not mean that I have really given you a cup of tea, right? still have to go and cook it on your own. So similarly, these people at Google, they prepared papers. Okay, the paper will talk about the design. Okay, how the system should be implemented to implement these two concepts called GFS and MapReduce. Wherein this GFS stands for Google File System. Okay, and MapReduce does not have any short form or long form. So this stands for Google File System. And what happened was, these guys looked into this paper, okay, and they understood that yes, this is what we were looking for, okay. And this GFS tells us how can the data be distributed in multiple machines, okay, and MapReduce says how the data can be processed in multiple machines. So these were just the theoretical paper, and this paper were basically studied by this team, Doc Cutting and Mike Affilera, and these people started implementing them. Okay, these people started implementing them, and after the implementation was done, it became Hadoop. Okay, these two papers, when implemented, they become a product called Hadoop. So in Hadoop they have implemented this GFS, but since in GFS stands for Google File System, they cannot use this Google name because they are working with Yahoo, right? Yahoo will kick them out of the job, so they renamed it like SDFS, removing that term GFS. Okay, so it is Hadoop Distributed File System, right? And then MapReduce was kept as it is because there was no name of Google at the end of the day, right? So the initial version of Hadoop came with only two concepts, that is MapReduce and SDFS, right? And what does this SDFS do? Hadoop Distributed File System. This says this will help us to store the data in many nodes together. Okay, so we can create a cluster out of it, and we can store all the data together in these machines. Okay, and what does the MapReduce do? They can help us to process the data. They can help us to process this data, whatever is stored in those machines. We'll go more detail into this. Okay, now how did they give the name Hadoop, right? So if I remember the history, and if the history is correct, whatever we get the information in internet, then it is said that Doc Cutting, a small kid, used to have an elephant toy, yellow color. Okay, and like babies are very good at creating new names, is not it? You'll really hear some crazy and fancy name from them. So that guy, the small kid was like murmuring something like a doop doop doop, something like that, right? And then they thought, okay, this guy is saying a lot Hadoop and all, so let us give a name called Hadoop because it is unique. Nobody has been given this name, so no problem with the copyright issue. It is short and quick as well, and that's where the name was given, Hadoop. Okay, so that's the history of your Hadoop. You should always know that when exactly it started. In India, people have started using Hadoop since 2010. I started working on this since 2012. Okay, and I know few people were using Hadoop since 2009 at least. I don't know about 2009 because that time I was still at college, no idea about that. In 2010, I started working in companies, and I saw that people were talking about Hadoop, and I was like, what is this Hadoop? And I never knew that I'll be spending a lot of years in Hadoop, and the market is really great. Okay, so I hope you understood what exactly is Hadoop, how exactly this MapReduce and SDFS came out of your Google papers, right? So there were two scientists, and if I remember correctly, one scientist is an Indian, Gautam some name, I don't remember the name, but we can just Google it out. So two scientists invented a paper, GFS and MapReduce, and at the same time, these people were in a lot of pain. They were crying almost every day because the servers, whatever they had, the resources, whatever they had, they were not enough. Every time it was going out of memory, in terms of storage, in terms of processing and all. So these people implemented these two papers and gave it a product name called Hadoop, right? And then Hadoop had a core component of MapReduce and SDFS. Okay, so currently, like if you talk about Hadoop comes in major three versions. Okay, Hadoop 1.x, Hadoop 2.x, Hadoop 3.x. This is relatively new. Market currently uses this, and this is completely gone. This is completely gone. Okay, nobody talks about Hadoop 1. They have a lot of limitations, and it is really old. Now everybody is using Hadoop 2. Okay, and I believe in coming 3 4 years, people will start using Hadoop 3 as well. Okay, because they don't immediately implement that. It takes little time to implement the recent versions. All right. So we'll move to the next. I want to see if you have any questions, guys. Amazing. So when you have no questions, there could be only two possibilities: you understood everything or you understood nothing. But I will assume that you understood everything because I'm trying my level best to make you understand everything. Okay. All right. So now what we will do is we will try to understand a little bit about this MapReduce and SDFS. Okay, so before moving to that topic, let me also talk about one simple topic, that is distributions, because it will also be very, very helpful to understand. Okay, so what we know is somehow dog cutting and its team, they have implemented Hadoop while they were at Yahoo. While they were at Yahoo, okay. But see, writing a software is very easy, but the main difficulties are maintaining it. Okay, so what these guys did, they gave it to Apache Software, Apache Software Foundation. Okay, so they gave it to Apache Software. Now this product is a part of Apache Software Foundation. Okay, they are open source. You can download Hadoop. You can look into the source code. It is implemented in Java, completely in Java. Okay, so they have given it to Apache Software Foundation, which is basically an open source tool right now. Okay, and then there are so many companies like Cloudera, okay, Hortonworks, Hortonworks. All right. Now these two guys are merged together. Okay. Now they are all Cloudera. No more Hortonworks. You have Greenplum. You have MapR. Okay. These are companies. These are companies. What they have done is they said, "Hey Apache, can you give me your Hadoop open source software? I will maintain it from my end. I'll hire my own developers, paying them a lot of money. I'll make your boring open source Hadoop software much more better by improving a lot of things, by solving a lot of bugs. And our developer will also help you to solve all the bugs wherever applicable. Okay, we will also help you that, as well as we'll also help you monitoring so that you can survive. Because see, open source Apache Software Foundation is a free community system, wherein if you want to be a contributor, you can. Okay, you can be a contributor. Apache Software Foundation will also pay you money if you are really very good developer building some nice product for Apache Software Foundation. Where do you think the money will come from? The money will come from companies like Cloudera, Greenplum, and so on. Okay, so since it is open source, these people are free to use it, and they implement it, fine tune it, hire their own developer, make the product much more better, and give it to customers like Apple, probably Google has their own implementation, so maybe Google will not be interested to take it up now. Maybe Amazon, they also have their own products right now, so they may not again take it. Okay, then you have uh, companies like Citibank, ICICI Bank, all other major customers, right? So these people basically sell the services. Okay, and they say this Cloudera and all this, they say, you take my product, don't take Apache software product, because in the middle of the night, if your system goes down, Apache software will not help you. Okay, they will simply sleep. Okay, but it is us who will provide you 24 into 7 so that your business is not impacted. Okay, and I was recently doing a consulting for a lot of US folks, and I've seen most of the companies are $1 billion company, right? $1 billion is, I think, 7,000 crores. They have a lot of money, right? So, and even those companies are such companies that we never ever heard about those companies anytime. We all know what is ICICI, or we all know Citibank, we all know this Morgan Chase and all, right? But what we don't know is a lot of small companies, or the companies whose name we have never ever heard, they're also making $1 billion easily in US, right? Because in US, it's very easy to make a lot of money. All right. So So now all these companies, they basically don't go and
There's a
buy, they
background
basically
noise.
don't go and try the Apache Software Foundation. Why? Because of one reason, that who is going to help them if their system stopped responding in the middle of the night, right? So that's the reason we have a Cloudera and other teams or other third-party distributions. We call it a distributions. What they do, take the free thing, fine tune it, distribute it. I mean, sell it. Okay, and they make a lot of money, lot of money. I remember, um, while I was doing a consulting for one of the company, we spoke to Cloudera. Okay, Cloudera team. We spoke to Cloudera team from some other country, and we asked them how much would you charge to set up a Hadoop cluster in maybe 10 node machine. Okay, so they
Sir,
said
एक
our
minute.
software
Sir,
is going
एक
to
minute.
cost $10,000
Sir,
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 per
एक
node.
minute.
Think about it. $10,000 per node. And if I had
Hello,
to
sir.
set up
Sir,
Hello,
in 10
sir,
different
sir, sir,
machines, then altogether they are going to charge
sir.
us $100,000.
Hello, hello. Wait, sir, sir,
That's huge,
sir.
is not it? From our
hello.
point of view. But that is really not used for people who are making $1 billion business. Right? So that's how it is, right? So they basically charge minimal money, which is very high for us, but not really good
Hello,
big
sir. We
for the
can't hear you,
companies like
sir.
Citibank or ICICI or JP Morgan
Hello,
Chase or any
hello,
other customers.
sir. Sir, we can't hear you. Hello,
Okay,
sir. We can't hear
so
you.
let me check if there are any people. Let me see if I can mute people. I think I can mute everyone.
Sir, सबका mic off कर दो.
All right, guys. Sorry for the disturbance. I muted everybody, so you should not hear the noise now. Okay. Now let's move forward. We will talk about we spoke about the distributions, right? So we have Cloudera, we have Houghton, Greenplum, MapR, and so on, right? So now what we will talk about is we'll talk about this Hadoop concept. We'll talk about what is this MapReduce. We'll talk about what is this SDFS. How do they work all together? Okay, so what the difference between Hadoop and Spark? I'll take it up at the end. Right now, we have not reached to that level. Okay, and should we have any prior knowledge of any programming language for Hadoop? Oh, I can take up that. Okay, so see, Hadoop development can be done mostly in two languages. Okay, if you are talking about Hadoop, you can basically prefer two languages, Java and Python, whatever works best. Okay, if you want to go with Spark, then you can still go with Java, Python, and Scala. Scala. Okay, so Scala with Spark, Python with Spark is a great combination. Okay, Java with Spark is very rare combination. I've seen companies using Spark with Java. I don't know the reason why they are doing it. The most important reason could be because they do not have a Scala developer, probably, or maybe a Python developer, or they believe JVM a lot, right? So Hadoop can be, like can be implemented using either Java or maybe Python. It works both well. And in Hadoop, you have a lot of ecosystem component like Hive, Scoop, HBase, where in most of the cases you don't need a programming language. In most of the cases, okay, there are some areas where you need some programming, like writing UDF, writing some clients. Again, these clients could be implemented either using Java or Python. Okay, so that's how it is. Let's move on. Any questions, guys? So Cloudera is okay. So Cloudera concept, can you please repeat? So see, Cloudera is a company who takes the open source software from Apache, right? They take that free Hadoop from Apache Software Foundation. They fine tune it. What are the bugs there are? What are the bugs available in it, or what is the limitation of it? They'll try to improve and optimize them, and then there's create a product out of it and sell it to the people. Okay, it's something like this. I go to like a farmer, get some rice from him, bring it here, and then create a packet called Suraj rice, right? And then sell it to the customer at maybe 50 rupees per kilo, whereas I have actually purchased it for like a 10 rupees a kilo, or maybe 2 rupees a kilo, right? So that's how it is. So Hadoop is an open source from Apache Software Foundation, and the companies like Cloudera and all, they take this up, they fine tune it, sell it to the customer with 24/7 support. and in the and at the same time they also contribute monetarily to Hadoop, as well as they will contribute solving some of the bugs of the Hadoop whatever they can, right? So that's how the community grows. So AWS can use Hadoop. Yes, you can have a AWS system where you can implement, where you can install Hadoop and make it work. So Amazon, they have their own big data solution. And if you say, no, I don't want to use Amazon big data solution, I want to use the Hadoop solution, I want to implement Cloudera software directly in AWS, that also can be done. Okay, so we'll talk about that. All right, any more questions, guys? Can I get no if you are all clear? Give me a no, then we'll get started. Okay, let me have my water. Okay, let's move on to the next topic now. The next topic now would be exploring SDFS and MapReduce. Okay, let us try to understand how do they work together all together. Okay, so before understanding that, let me explain you some terminologies. Okay, number one, node. Okay, so there's a confusion. What do you mean by this node, right? So I'll say node is basically a machine with its own CPU, with its own memory, with its own disk, hard disk. Okay, so every node, when we say I have a 10 node cluster, right? So that means I have 10 machines. 10 node, 10 node means 10 machines, and every machine will have their own CPU, memory, and disk. They do not have a fancy monitor. Sorry, okay, you don't see a fancy monitor. They are just a system with no monitor at all. CPU, memory, and disk. They are called as a node. Next, you have cluster. What do you mean by cluster? Okay, cluster means nothing but a combination of multiple nodes put together. Okay, so if you see, I have joined 4 nodes together in a network, and I can call it one cluster of 4 node, right? So we call it a cluster of 4 nodes, right? Okay, now let us, having understood this, let us try to move forward and understand this SDFS. SDFS stands for what? Hadoop Distributed File System. Okay, SDFS stands for Hadoop Distributed File System. That means the file system would be created in such a way that it can distribute the data. We'll take an example to understand it. Okay, now suppose I have one file of say 200 MB or maybe 300 MB. Okay, I have a file of 300 MB, right? Now if I have a file of 300 MB, what will happen? You know, if I want to store this file into this SDFS, then this file will be splitted into parts. This file will be splitted into parts and they would be stored. Okay, I'll take an example. Let's take some other example and we'll get back to this example again. Okay, suppose you have your birthday and you bought a piece of cake, right? And then this cake is around, let's say 2 kilo, right? And then you have to give it to what? You have to give it to your friends. After you do a cake cutting, you'll basically split them into many pieces and you give each pieces to your friend. Okay, so to give it to your friend, what you have brought is small plate. What you have is a small plate, right? All small, a small plate. Now can I keep this 2 kilo of cake in this small plate? No, right? It will not come. It's not it, because the volume of this and then the volume of this is really different. So maybe let's assume this small plate has a capacity of 128 gram. Okay, this small piece can hold only 128 gram of cake, not 129, not even 30. It can still store 120, but not anything beyond 128. Okay, so what you should basically do is you split them. 128 will go here, another 128 will go here, another 128 would go here, another 128 would go here, another 128 would go here, right? and leftover, if they are 128, then they would go in a different system. Okay, so what are we actually trying to understand is a big cake of 2 kg were divided into multiple of 128 grams. Why? Because every small dabba is capable to hold only 128 gram of your cake. Okay, now let us try to correlate this with this example in our SDFS. So in SDFS, the data are always stored in form of blocks. Okay, one block size would be 128 MB max. It can be configurable, but I'm talking about the default. So in Hadoop 2 and 3, the size of this block is 128 MB, which means if I have a big data which is more than 128 MB, then they would be always split into multiple of 128 MBs. Okay. Having said that, if I have 300 MB of data, okay, now this 300 MB of data has to be stored. Now look into this. This is one node. Let's talk about the capacity. Okay, the capacity of this machine is, let's say, 4 cores, 32 gigs of RAM, and 1 TB hard disk. Okay, so 4 cores, 32 GB of RAM, and 1 TB of hard disk, and we have 300 MB of data, right? This 300 MB of data has to be stored here. How? By dividing the data into pieces, is not it? So what will happen is the data should be divided into pieces. And what would be the piece size? The piece size would be 128. Okay, so you should break this data into 128 MB. Okay, so it is a file, right? So the file would look like this. If the file would look like this, so many lines, right? So maybe this line is 128 MB, this line is another 128 MB, and so on. So let's divide this. Okay, so this file, the file, let's say the file name was data1.txt, is broken down into parts. I'll say part 0, part 1, part 2. Okay, so part 0 would be 128 MB. Part 1 would be another 128 MB. How much it became now? 128 and 128 is 256. What is left over? 44, right? 256, yeah, 44. So 44 MB. So this big data, data.txt, which was of 300 MB, were literally divided into 3 pieces: part 0, part 1, and part 2. Okay, the first part 0 would be stored here in this machine, part 0. Okay, part 1 would be stored in this machine. Part 2 would be stored in this machine. Okay, so see here, even though the data was only 300 MB, and the cluster, if you see this, all these machines have the capability to store 1 TB of data, it does not store that complete 300 GB of data here. It will always divide, no matter what. Okay, it will always divide all the data into 3 parts, into n number of parts, right? In my case, since the data was only 300 MB, the data was split into 3 parts. Okay, so part 0 is here, part 1 is here, and part 2 is here. That's how the data would be distributed and stored. Okay, now the question is, if I have 1 GB of data, how much piece it would be divided into? How much pieces it would be divided into? So 1 GB means what? 1024 MB. What the block size? 128 MB. Okay, and if you divide this, then it becomes 8. That means if somebody gives me 1 GB of data to be stored in my SDFS, then 1 GB of data would not be stored directly. It will be divided into pieces, right? It will divide into multiple pieces. So I will have 8 pieces altogether. Okay, and all these 8 pieces are called blocks in Hadoop. Blocks or split in Hadoop. We'll talk about the difference later. Okay, but we call it blocks or split. Okay, so block 0, block 1, block 2, block 3, and maybe block 4, block 5, block 6, block 7. So 0 to 7 is 8, right? So that's how the block would be divided into pieces, and they would be stored in your all your nodes. So they don't get stored in a single machine. Even though you have a capability of storing 1 TB of data, all the data would be always divided into multiple pieces. All right, questions, guys? Can I get no from everyone if you are good till here, and we'll move to the next discussion. We'll talk about map reducing a little later. Okay, we are right now exploring what is SDFS. Can I get no, please? We'll talk about map reducing later. Okay, we are now focused on SDFS. Can I get no from everyone if you have no questions till what we have studied now? Great. Does Hadoop uses FIFO? They are a part of scheduler. We'll talk about that later. It will not be advisable right now to talk about those concepts. Okay, so we'll talk about later that. Okay, so let's go step by step. All right. So I'll answer your questions, right? Let me finish this topic now. Okay. So we were talking about SDFS, right? So in SDFS, what we understood is data will always be divided into pieces, right? So let's say you have a 4-node machine, 1, 2, 3, 4. You have a 4-node machine, and in this 4-node machine, what exactly you are trying to do is you are trying to store a file of, let's say, 300 MB, right? That's what we were talking about. And since the block size is 128 MB, it will be divided into 3 pieces. Okay, so each piece is called as a block, right? So block 0, block 1, block 2. So block 0 is of 128 MB. Block 1 would be another 128 MB. Block 2 would be leftover. 128 is 256. 256 plus 4 is 60 and 44 MB. Okay, so when I want to store this data, let's say data.txt. If I want to store this data.txt of 300 MB, this will be literally broken down into 3 pieces, block 1, block 2, block 3, and they would be stored here like this: B0, B1, B2. Okay, that's how the data would be splitted and stored. All right, now when the data is stored like this, why the data is basically broken down and stored? The reason is because if I want to process this data, the data can be processed parallelly. Okay, like the same, we will write some MapReduce job, right? The same MapReduce job will execute here. The same MapReduce job will also execute here. The same MapReduce job will also execute here. They will work on this code. They will work on this data. They will work on this data, and ultimately, whatever data you get, they would be combined together, and you'll get the output. Okay. Now let us understand that with an example. Suppose this file contains information like this. Okay, I'll write some data here: 101, 102, 103, 104, 105, A, B, C, D, E. Okay, and then I'll say 50, 70, 20, 90, 100. Okay, so now if you see, this is my file, a sample data.txt, a sample of data.txt, and we have some records here. Now let's assume these two are in B0, these two are in B1, and this is in B2. And the objective of the program is find out highest score. The objective is find out highest score. So what will happen, in this B0, I have only two records. In this B1, I have two records. And in this B2, I have only one record. So what will happen when we write our job? The job will be a MapReduce job. We'll see how to write that later. But right now, let's try to understand. So when we write the job, we write a MapReduce job and we schedule it. We say process this job, process this data using this job that we have written. And what does that job do? The first job B0, the first data, right? So this B0, the first data has two records. So my code will work on these two data set and say which one is highest, 70. Okay, again it will check this, which one is highest, 90. I will check this B2, which one is highest, since I have only one record, 100. So from every data I got some highest mark, is not it? And then that highest mark would be again recomputed. I say, okay, I got the highest here, I got highest here, I got from highest here. Now let me find out who is the highest among these three. 70, 90, 100. 100 is highest, and that's how you get the information. So see, now this would basically be a little faster because one guy is not working. to get this job. 3 people are working together. The one guy is processing 2 records, the other guy is processing another 2 records, the third guy is processing 1 record, and then the output of these 3 guys were again merged to the 4th guy, right? The 4th guy, I will not say B because they are not block, they are the processors. So this output would be brought together, and again we will find out the global, like highest out of these 3 local highest, and that's how it works, right? Anyways, so we understood that how the SDFS basically stores the data. It basically stores the data by dividing the data into blocks B0, B1, B2. Okay. Now, all these machines are what are called as commodity hardware. Okay. So if you look into any Hadoop books, Hadoop says this node need not be a super expensive, powerful system. Okay. These nodes can be a simple machines. So in a real time, what happens? All these machines will not be expensive. Okay, will not be expensive. This would be cheaper machines. So when I say cheap, you may ask me how much cheap? 20,000 rupees? No, that is cheap for you, but that is not cheap for company, right? So company would still spend a lot of lakh of rupees for these machines. Okay, but that is cheaper for company, not for you. Okay, so we will talk about Hadoop, that they work on the concept of master and slave. Okay, we have some master machines, we have some slave machines. We'll talk about that later, but right now we're just focused on this SDFS, right? And let's say we have a 4 node where the data would be stored, right? And the first node, second node, third node, fourth node, and all these nodes are basically the cheaper machines. Okay, as I have told you, cheaper for companies, not for you. Whatever looks cheaper for them, that is still very expensive for us, is not it? Anyways, so the data would be stored like this. Okay, and since they are cheaper machines, there is always a chance that one of the machine may fail, possibly, yes, right? For example, you have 4 node machine here, right? And let's say this machine failed. Now if this machine fails, then what is the problem? Nothing, you just lose one data, is not it? But that is a problem, that is the biggest problem. You want to process the data and you realize that the data is no more available because the node is completely down. What would you do? As a developer, I would go home, right? But as an admin, you have to bring it up because the data is gone. So this is really very important, that the data should not be lost. If the data is lost, then Hadoop is no more reliable. Nobody would use Hadoop system, right? So Hadoop says, let us do one thing. Let us try to replicate the data. Let's duplicate the data into many other places. Okay, so let us store the data in many different places. So what does Hadoop do? Hadoop says, okay, I have a file, data.txt, right? The file was of 300 MB. We divided this file into 3 parts because the block size is 128 MB, right? So 128 MB, 128 MB, and 44 MB. We divided this data into multiple pieces. Now this data is residing here: B0, B1, B2, right? Block 1, block 0, block 1, and block 2. Now, since we know that these machines are cheaper machines and it may fail at any time, what we'll do is we'll replicate, that means duplicate. So B0 is B0 is here, I'll create one copy of B0. B0, I'll write C, okay? That means the copy of B0, okay? And again, let me copy it here as well, B0, C. I copied this B0 in 3 different places. One is original and 2 are copies. I'll say C1 and C2, okay? That means the data is duplicated. For example, I have got some important videos of my life, my marriage video, right? My kid's birthday video. So what I will basically do is I'll not save it in my system, a single machine, because I'm always afraid that what will happen if I lose it. What I'll do is I'll copy it in my laptop. I'll copy it in my brother's laptop. I'll copy it in my family's pen drive or disk. I'll keep it on my Dropbox. I'll keep it in so many places because I don't want to lose it at any cost. Is not it? So similarly, the data are splitted and the data are replicated, right? So this B0 is the original copy. This copy is copied here. This copy is also copied here in 3 different places. The replication factor, we call it replication, okay? Data is getting replicated. So the replication factor by default is 3, which means by default, it will be copied in 3 different places. Why? Because if this is gone, then also I have 2 different places where the data is available. If this is gone, then also I have one more place where the data is available. If everything is gone, pack your bag and go home and enjoy, right? Because we cannot do anything if the whole cluster is down, okay? So So in the real time, that should not happen. Okay. So basically, as I told you, these systems are cheaper, but they are not so cheaper from company's point of view. And the chances of getting failure are very, very minimal. Okay. So B0 is copied here as well as here. Similarly, B1, this is the original copy, right? So we will have one copy here probably and another copy here probably. Okay. Again, B2 is here. So I'll have another copy maybe here. See, B2 is here, right? So I will not copy B2 here again. That does not make any sense, right? So B2, I will copy it here, and B2, I will copy it here, right? So likewise, the copy would be, generated, and the copies would be distributed everywhere, so that whenever we want to process the data, if this node is down, no worries, I have copy in other system, right? I have the copy maintained in other system. That's how basically SDFS works. Okay, so SDFS is a distributed file system which stores the data by distributing them, by splitting them into multiple of 128 MBs, right? They would be stored like this. And since they have stored the data here like this, now the next thing what it does is it also replicates, so that the data is duplicated and kept everywhere, whatever possible. The replication factor is 3. You can change it to 2, you can change it to 1, you can change it to 10. If you change it to 10, then the biggest problem would be you need 10 times more space, right? If you change it to 1, then the biggest problem is if you lose that original data, if the node is down, then you lose the data because you do not have a replica. So ideally, every company uses 3. Okay, replication factor. I've never seen any company using a replication factor of 4 or 5 or not even 2. Everybody goes with the default replication factor of 3. Of course, that can be configured and changed. All right. So let me check some of the questions. Can you change replication factor? You can change the replication factor. This is what we have already discussed. Sir, but we have just 128 MB and how we can store again? See, 128 MB is your block size. 128 MB is your block size. You can change the block size as well. Few distributions come with a block size of 256 MB. Okay, this can also be changed. You will see them while installing Hadoop. They are configured. They can be configured in your XML file, and you can change it very easily. Okay, what is the size of a SDFS node? All right. So you mean how many node can we have in the production? Is that your question, Sasank? What is the size of a SDFS node? Or maybe you're talking about what is the size of this machine? A single node. Okay, so see, a single node can have 4 terabyte of storage, 8 terabyte of storage, and so on. Okay, so it depends on what volume of data you are actually processing. Depends on how much volume of data you are actually willing to process. Okay, so it may go around 4 TB, 8 TB, even 2 TB. It depends. Like if you go with some of the cloud provider, they have their own instances. Every instances have their own configurations. Okay, and that you can check it out with the cloud, whatever you're going to use. Not SDFC, SDFS. Okay, total number of nodes you can attach. So Yahoo is believed to have a largest Hadoop cluster of 4,000 nodes, and it can go up to 10,000 as well. Okay, let me share a screen. I'll show you that. That's really interesting to see. So I'll share my screen. I'll go back here. And I'll say Yahoo Hadoop cluster. Okay, yeah. So let me go to image. Okay, now look into this example. Look into this example. Okay, so this is basically the real cluster. Okay, so if you see, these all big boxes are called as rack, right? So rack 1, rack 2, rack 3, rack 4, rack 5, rack 6, rack 7. There are 7 racks. And here if you see, you can see a small compartment, right? So these are all one node. So here 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 into 4, 80. So this host 80 node probably on this side, okay? And if you see, there is a backside also. So 80 and 80, 160. So this one dabba, right, one compartment is holding 160 node. 160. So now 1, 2, 3, 4, 5, 6, 7, 8, 9. 160 into 9, whatever. That many nodes are available. Here at the top, you have switches. So this is how it looks like, okay? Now, whenever you are using Amazon, AWS cloud and all, please understand that AWS has put a lot of effort to create a data center like this in the backend. Of course, that is not visible to you, but at the end of the day, there is no real cloud. It's always, you're always using somebody else's machine, right? And likewise, Amazon also creates this kind of cluster. They store it on their area, and they give you the service out of it. That's how basically it works. There is nothing in the cloud. Cloud can only give you rain and snow, nothing more than that. All right. Let me check. What's the difference between Hadoop admin and Hadoop developer? Hadoop developer would be basically responsible to write, a processing logic. They would basically work on how do I write a logic, to process big data. You need to have a programming knowledge. There would be a lot of demand for Hadoop developer than admin. What Hadoop admin do? They basically manage the cluster. Okay, they do the setup for you, and they configure a lot of systems, like a lot of users, permissions, securities. All these things would be taken care by your Hadoop administrator. Hadoop administrator jobs would be very less, because see, in any company, how many developer would be there and how many admins would be there? 10 developer, 2 admins. That's how it would be. Okay, so the total number of node that you can have is 4,000 to 10,000 in Hadoop 2 and 3. All right, any questions, guys? Please feel free to ask me anything, whatever you want to, because it is you who have to, clarify the doubts, not me. See, when I was working with Apple were using Cloudera, right? And it is possible that many company may use their own vendor. So most of the bank company, they may not agree to have a cloud because of the data security issues, right? So most of the bank, they would say, we want our own cluster. Okay, so they may install their own cluster, and in their own premises they may install Cloudera. That is practically possible. Okay, so you can buy, see, if somebody wants to install their own cluster, then they will have to buy a rack like this. Okay, and who provides this rack? Companies like Dell, they provide this kind of rack based servers. So if IBM wants to use it for any processing, and let's say if they are not ready to put the data on the cloud, then they will have to install this on their own premises. All right, so I think we will stop here today, guys. Yeah, we will talk about the MapReduce tomorrow. Okay, we'll stop here today. I believe we will again resume our session tomorrow. Cluster is basically, I would say a group of more than one machine, right, put together in a network, right? For example, you go to a college, in a single class you see many students, so that is a cluster of student, is not it? A group of student. So cluster is nothing but a group of computers put together in a network. Okay, does Hadoop work on ETL? There is a difference between ETL and Hadoop. All the ETL developer now wants to learn big data. Okay, why? Because ETL cannot scale up that much. You talk about any ETL, ask them, can I have 1,000 node cluster? That is not possible. And that is where Hadoop is the market leader, right? ETL developers are now learning big data. Your Informatica and all, there are people who are also using Talend and all. They are all ETL tools. So these people are also migrating to Hadoop. Okay, you can do ETL kind of job in Hadoop, but Hadoop would be much more faster, because at the end of the day, you can have 10,000 machines working parallelly for you. Okay, yes, this session I have recorded this session. I'll share it with the team, and you can get it from them. Okay, so wait for their email, and then you should get this link.